Welcome back. This is an Aleks training video on calculating the heat of reaction from bond energies. Bond energy is the amount of energy that is released when a bond is made. And it's the amount of energy you have to put into a bond in order to break that bond. So if you were to have a table, and Aleks has tables of all of this in the data, under the data tab, you would look up the tables of all the enthalpies. So here you've got three different species. You've got hydrogen, so you have a hydrogen-hydrogen bond enthalpy. Looking it up now, hydrogen-hydrogen. So hydrogen-hydrogen is 436 kilojoules per mole. Then you have chlorine-chlorine. A chlorine-chlorine bond is 242 kilojoules per mole. And a hydrogen-chlorine bond is 431 kilojoules per mole. So I just looked that up. That's just in a table. So if you are going to do this problem, you are going to have to add whatever energy it requires to break all the bonds on the left, and then you'll get the energy back as the bonds are made on the right. All right? So you're going to have essentially energy of breaking, okay, minus, so this is the total energy, which is called enthalpy, the energy of breaking the bonds on the left, and then you're going to get back, that's why it's minus, the energy of making the new bonds on the right. Okay, breaking the bonds on the left, making the bonds on the right. So let's look on the left. What do we need to break? We need to break one hydrogen-hydrogen bond. Okay, so we're going to say that will be 436 kilojoules per mole. Then we need to break one chlorine-chlorine bond. So that will be 242 kilojoules per mole, right? And now what bonds do we need to release? So this is on the left. On the right, what are we going to need to release? We need two bonds because it's two HCl's. So it's two bonds of the 431 kilojoules per mole. And so if you want to find the total enthalpy, and that's what it says, calculate the heat of reaction for delta H for the following reaction. So delta H is going to be this, the left, all the energy added up to the left, minus all the energy added up on the right. Okay, so if you add 436 and 242 together, you're going to get 678 kilojoules per mole. And then you're going to subtract 2 times 431 is 862. 862 kilojoules per mole. And that gives you a total enthalpy change of negative 184 kilojoules per mole. So what that means is when you have a reaction that is hydrogen breaking its bonds, chlorine breaking its bonds, and then new bonds being formed for hydrogen chloride, you're going to get energy back. It's going to be an exothermic reaction, fully exothermic reaction. On the left, it's just adding energy. On the right, it's getting it back. But when you take all of it together, you're going to get back a certain amount of energy. You're going to get heat or an explosion somehow. If you were going to take hydrogen chlorine, you could probably get a fireball when this is made. But that's what it's telling you, that you're dumping energy as a result. There was more energy stored in hydrogen and chlorine bonds than there is stored in the HCl bonds. Okay, thanks.